During our laboratory experiment number 6, we're going to conduct direct tensile strength test. The objective of this experiment is to become familiar with the method of determination the tensile strength of rock materials using direct tensile strength test. The ASTM standard method of test for the direct tensile strength of rock core specimens specifies that the core diameter should be, if possible, not less than 1 7/8 of an inch, which is basically NX wireline size, and that the length of the core should be between 2 and 2.5 times its diameter. The same standard is used by the U.S. Army Corps of Engineers in their rock testing handbook. The equation for calculating the average tensile stress, T0, at failure is basically applied load at failure divided by cross-sectional area of the sample. The rock samples are first glued to the steel platens using 2-part epoxy glue, and you can see on the samples that we're going to monitor the deformations, and then we're going to convert those to strains using 2 sets of strain gauges. So we're going to have strain gauges which are going to measure the strain in the axial direction and also in lateral direction. Those are lateral strain gauges, and also we had strain gauges measuring axial deformations. So these steel platens have threaded ends, and we're going to attach those threaded ends to the attachments connected to the loading frame. So both ends of the sample are going to be attached to the opposite ends of the loading frame. The photograph on the right shows our monitoring equipment. So during the test, we're monitoring both the stress applied on the sample, but also the lateral and actual strains, and each sample is equipped with 2 sets of both lateral and axial strains, and this is done basically as our insurance in the case if one of the strain gauges malfunctions during the test. We can also always obtain the data from the second set of strain gauges. So let's take a look at the test itself. So we're hoping that the sample is going to fail approximately in the middle of the sample length. So this black line shows exactly the center of the sample, and we're hoping that the sample is not going to fail at the glue joint. Okay, so we have almost ideal failure of the sample. We can also note that strain gauges are destroyed after each test. So with a new sample, we have to attach another 2 sets of strain gauges. So for your lab report calculations, use the attached Excel file with the collected data. And first of all, calculate the ultimate tensile strength of the tested rock sample, plot stress strain, and then after the stress strain plots have been made, determine Young's modulus by using the tangent method. So we are going to use this tangent method at 0 stress and also at stress equal to 50% of the ultimate strength. Also compute Poisson ratio at the same 2 stress values, so at the beginning of the test and at the 50% load applied to the sample. So compare those 2 values of Poisson ratio based on your calculations.